I don't know.
So if you're proving it by contradiction,
I literally don't know.
start by assuming the opposite. So assume um, that square root of 1 over 2 is equal to, I believe, a over b, where a and b are integers. So maybe we should just kind of go back to the where it comes from. Yes. So you assume that, so if it's root 2, you would assume that root 2 is equal to a over b, where a and b are integers. And so it can't be reduced any further. You then square both sides. And then you show that both numbers are even numbers, which we know it can't be because it can't be reduced any further.
So after half equals a squared over b squared, then what do you do?
So a half is equal to a squared over b squared. Then let's say make it 2 times something equals something else.
So you times both sides by 4.
Um,
What?
you could
2,
times both sides by 2 would work.
but then wouldn't that be 1 equals?
Yeah, so 1 equals
2 squared over 2b squared.
over b squared, because 2 is the same as 2 over 1.
Oh yeah.
Then make it so it's not a fraction.
B squared equals 2a squared.
Yeah. Okay, so do we then? So basically, a squared is double b squared. Do we have, so hang on, 2a squared, does that show that it's an even number? This means that a squared must be even, so a is also even. Yeah, a squared is even, so a must also be even.
Okay.
So we now show that b squared is also even. Have we already shown that? If a is even, then it is expressed in form a is equal to 2n. Okay, a is even, so a is equal to 2n. Sub it in. So sub in 2n for a.
(16n squared).
I believe it would be 8n squared.
Which one are we subbing into? The b squared equals 2a squared.
Yeah.
So then you get 4n squared, then you don't just square the 4.
You get 2 times 2n squared.
Yeah.
What is that?
Oh, you do the brackets first. Yeah, okay. So 4n squared, 8n squared. Okay.
So b squared is equal to 8n squared. So that could be written as 2 4n squared, I suppose. What does that tell you about b squared?
It's even.
That shows you b squared is even. So
B is even.
So b is also even. What is the contradiction?
That it would be an irrational number.
We said a over b is fully simplified. But two even numbers could both be divided by 2, and so it's not fully simplified. And so it's proof by contradiction. So let's take a look at the exact thing for this. So this is one. Next exercise. Yeah. So assumption root 1 over 2 is a rational number. Then root 1 over 2 is equal to a over b for some integers a and b. We also assume that this fraction is in its simplest form. A half is equal to a squared over b squared. 2a squared is equal to b squared. So b squared must be a multiple of 2. So b must be a multiple of 2. They used c instead of n. Therefore, a is a multiple of 2, and they did b first and a second. If both a and b are multiples of 2, this contradicts the statement that there's no common factors or that it's fully simplified. Therefore, it's irrational. So first you let it be equal. So if it's a rational number, so if we have to prove that it's irrational, we first assume that it's rational. And a rational number can be written as a fraction with integer over integer. So prove number is irrational. So 1, assume that it's rational. Equate number to a over b, where a and b are integers, and have no common factors, so they're fully simplified. Simplified. Square both sides. make like 2 times, let's say, show a squared is even, so a is even. And you do that by having it in the form of like 2a squared. Show b squared is, no. Let's say sub 2n for a. Show b squared is even. Both even. 2 is a common factor. Contradicts our assumption. Therefore, irrational. It's that easy. Let's see, that was root 2, root 1 over 2. Let's do prove root 6 is irrational.
So root 6 equals a over b. That means 6 equals a squared over b squared. Assuming that root 6 equals a over b, where a and b are integers and all that.
And what's the second thing?
6 equals a squared over b squared.
Second assumption.
Rational.
So that's implied by integers.
Oh.
What
no.
else do we say about A and B?
Even.
They have no common factors.
Oh.
So it's fully simplified.
Okay. And then 6b squared equals a squared.
Mm-hmm.
So that means b squared must be even.
So another way to write that is that A squared is equal to 2 times 3b squared.
Yeah.
So if A squared is 2 times some other number, that means that A squared is even.
Yeah.
Yeah.
And therefore a is even.
Mm-hmm.
And then you put the 2n thing in.
Yeah.
So 2n squared equals n squared equals 9 times 18 b squared.
It's equal to 6b squared, isn't it?
Yeah, but then you did that the whole factorising thing. So then I just did that. Oh, that b squared's over everything. Over. Okay. Yeah, 6b squared. And then do you just take a factor of 2 out?
So I'd write it as 4n squared is equal to 6b squared, and then make b squared the subject.
Four n squared over 6.
Yeah, so you could write that as 4 over 6n squared, and then take a factor of 2 out of that.
So 2/3 n squared equals b squared.
Squared. Yeah, what does that tell you?
That b squared is even.
Yeah.
Therefore b is even.
Yeah. What's the significance of that?
That contradicts that a over b is fully simplified because it can be divided by the both factors of 2.
Yeah. Therefore,
Yeah, it's a rational number.
yeah. So therefore, a over b is irrational, and therefore root 6 must be irrational. Any questions about that?
No.
Tricky stuff. Oh, do I dare? Alright, I dare. Okay. Yay. Some more normal. Let's try question 4.
many times? Just 3 over 5. You just like times the tops and times the bottoms, don't you?
So I'd fully factorize the top and bottom first.
What is vert? So top we have x minus 2 over x minus 4, x plus 1 times x plus 1 x plus 5 so then we get 2x x minus x plus 5.
Say again, sorry?
Yeah, I got that.
Okay.
Yeah. And then do you times them? Do you want to cancel?
Cancel first.
So there's a x plus 5 there, x plus 5 there, x plus 1, x plus 1. Can you do that?
Yep. So if you were to multiply them, 2 times 3, 3 times 2, you can split them back up.
Okay. So we have 4x, x minus 2 over 2x, x minus 4.
4x, x minus 2 over 2x, x minus 4. Can we make it even simpler?
Yeah, and then 2 x minus 2 over x minus 4.
Yeah.
Yeah.
Okay. How are we doing this?
What? B. Are we on the next question, yeah?
Yeah.
Okay. Given that ln of the top row equals 6 plus ln of the bottom row, find x in terms of e. So ln. So can we put like 2x minus 2 there?
I would put the two lawns together on the same side.
So ln of that minus 6 minus. Okay, ln of that minus ln of. Oh wait, when you minus, is that the same as like log where you divide, or is that not the same thing?
Yeah, because ln is just a type of log.
Okay. ln 4x squared minus 8xx squared plus 6x plus 5 over the other stuff.
And does that stuff look familiar?
Same as ln 2 minus 2 over x minus 4.
Slán. Yeah, okay. 2. You could say 2x minus 4 over.
Yeah, true. I won't do that. Now ln 2x minus 4 over x minus 4 equals 6. And then should I put the x minus 4 onto the other side and then do the e thing, or?
The x minus 4 is in the log, so you can't move it to the other side yet.
So then do you take do you just put e in then?
Yep.
So 2x minus 4 over x minus 4 equals e to the 6.
Mm-hmm.
And which it's called and then e to 6 times x minus 4.
Mm-hmm.
And basically just make x a whatever it's called.
Subject.
Yeah. Oh, how do you do that?
So I would expand the e to the 6 bracket.
Okay, so e to 6. Was it x e to 6 then?
Yep.
Okay. X e to the 6 minus 4e6 equals 2x minus 4.
Mm-hmm.
And then add 4 equals 2x. And then how did you get the other x to the side?
Say it again.
I don't know what you done.
So I just expanded the brackets and then brought the x's to one side And the numbers to the other side? And do you know why I did that?
Oh yeah, hang on. Sorry, I got all confused because you put your X in the right different way around. Then do you take out X to the factor? 2 minus e to 6 equals 4 minus 4e6. Then X equals 4 minus 4e6 over 2 minus e6. And then can you simplify?
You can, yeah. Oh, no, I don't think you can simplify it, actually. 6 over. Is that what you got?
Yeah.
So e to the 6 would have to be an even number to simplify that. That's it. So you're using your part A to do part B. Fully factorize, fully cancel down, and then you kind of notice that it's similar to this one. Bring the lines together, and so it's one over the other, just like the part A, and so you can just do part B like that. E both sides, get rid of the fraction, and then get the x's together and factorize. Easy peasy. Easiest 3 and 4 marks you'll ever get. Let's see. How about question 5? Do you think you'd be okay for that, or you want to do it?
Yeah, we can do it. Actually, no.
I think you're good for it. How about adding? So question 6.
6. Yeah, you just cross multiply and do the same thing, don't you?
So common denominator and stuff. So you're not solving.
So like, as in, you times the left side by x squared minus 3x minus 10.
So
and times the other side. Like cross multiply it and then have the 2 under this.
Yeah, and I'd factorize it first. So I think it's I'll make your life a bit easier. Let's do the first bit. What do you get when you factorize the second denominator?
X minus 5 and x plus 2.
And so because the other denominator already has an x minus 5, you can use that. So what would be your common denominator?
X minus 5, x plus 2.
Yeah. And so that's x minus 5, x plus 2. And so what goes on the top?
11x plus.
U times the bottom by x plus 2?
Yeah, so times the top.
Yeah. So you times the top by x plus 2 as well, and then you just go from there. Any questions with that? No. Okay, so because they had a thing in common on the denominator, you could avoid that. So 7 is just 3 fractions. Do you think you'd be okay for that? Or you want to do it?
Sure, fx equals x squared, so yeah, we can do it.
Okay. So I want to try starting it. And the easiest way is to just add the 3 together and hopefully you end up with what they have.
Yeah. So you factorise the bottom of the third one.
Mm-hmm.
So you get x minus 1, x plus 3. Oh yeah, you already done that. Oh. And then 3 already has an x minus 1. So you times the numerator by x plus 3. And then the bottom's x plus 3. And then you times the top of the other x by both of them.
Yeah.
Over the. Yeah. And then do you flip the third one and then add it? Or do you want to do something before that?
You only flip it if you're dividing it.
Oh, can you just minus that normal?
So you just like a normal fraction.
Oh, okay. And then, yeah, you can expand them, I suppose. Makes the life a lot easier. So, x cubed plus, so x squared. So you times that by x, you get x cubed plus 2x squared minus 3x. Over. Oh yeah, okay. And then 3x plus 3x plus 9 minus 12 all over x minus 1 x plus 3. So then we have an x cubed.
And I wouldn't, don't expand the denominator.
No, I didn't.
Okay.
I'm just doing it the top one. X cubed minus 2x squared minus 3x plus 3x gives you nothing. 9 minus 12 is minus 3. What?
Yeah.
Over x plus 3 x minus 1. Then factorize the top.
Mm-hmm.
So we have 1 minus 2, 0, and minus 3. What? 1 minus 2x squared. 0 minus. I'm not getting a good number.
So I got x is 1.
I'm not getting that. Polynomial 3 degree 1 cube minus.
So if x equals 1, did you do 0x for it?
3, 1, 2. Yeah, x equals 1. So x equals 1.
And so one of the brackets is x minus 1.
Yeah. So then it's x squared. Okay, whatever.
Yeah, so the second bracket will be x squared. And is there any way for us to... Okay, what's the number at the end?
I literally don't know how you do this backwards.
So x times x squared makes x cubed.
Yeah.
What will make minus 3?
Minus 1 and plus 3.
Yeah. Now let us cheat and use the question, and they don't know we didn't do it in our head.
Yeah, 3x and then over x plus 3, x minus 1, then those cancel out, so you get x squared plus 3x plus 3 over Well, great.
That's it. Well, there you go. Any questions there?
Nope.
Okay. And good use of the calculator. This is partial fractions. How are you for those? Question 8.
I can do partial fractions.
Okay, so these are all partial fractions. Is there a trick with that one? There might be. Alright, you said you can do partial fractions. I'm happy. Yeah, they always tell you what form to put it in. You see question 14? Do you know why you're getting these that don't have that's kind of special. That's very, very special. Basically, it's because it's an improper fraction. Yes. So let's say question 17 is more representative. So on the bottom is x squared, and on the top is 2x squared. So this must be bigger, and so that's why you have the a, the extra a.
Yeah.
So I'll just be a number. Okay, so that's chapter 1. I'm happy enough there. Where's my thing gone?
I reckon I should have to do algebraic division then do it again.
Not necessarily. There's many different ways to do it, but if you're confident enough with it, then that's the main thing. How about these?
I have a calculator, to be fair.
What, for the partial fractions?
No, that's not partial fractions, is it?
Sorry, so you meant you'll just do these in your calculator, is it?
Yeah, that's just modulus, isn't it?
Yeah. Okay. How does this question 6 work with these two things?
Sketch the graph for that. Fx is defined by that. So I'll do a little table and then do from -2 to 6 and find what the things are from -x and x minus 2, and then I'll just draw them. I feel like you can on your graph, but I don't know how to do it on my calculator.
So the way it works is so you see how for the top one x is less than or equal to 1?
Yeah.
So you would sub -2, -1, 0 and 1 into this one, y equals -x, and you would sub 2, 3, 4, 5 and 6 into this one.
Yeah.
So it's two different graphs, and you would do that. Are you confident enough with that?
Yeah.
How would you do part B?
For which fx equals -half. Don't know.
What is the f of x equal to?
What is the f of x is that? So like, do you have to just make? So do you just go -x equals minus? No.
Yeah. -x equals
minus
a half. Yep. And what else?
To x equals a half.
Yep.
And then x minus 2 equals -half.
Yeah.
And then just work it out.
And yeah, and I think you get 1.5. So you get two different answers. And if you were to draw those graphs, basically there's two x's that have the same y coordinate. And that's a many-to-one function. What is this about p of q of x?
Which question?
7a.
Functions p and q are defined. Find an expression for p, q. So you put qx into p. So 2x plus 1 into x. Then work it out.
Yeah. I think you're okay there. Okay, this one. Range. How do you do that?
The range of the inverse is the domain of the normal one.
Okay, so this is the normal one.
So
they just give you 2x plus 7 and they say what is the range.
Oh wait, where are we? I'm looking at the wrong. 8. The function gx is minus 2x plus 7. So what? Determine inverse of g, which is 2. Wait, you differentiate, don't you? Yes.
Slow down. Part A. Find the range.
Oh, I saw a sketch. Hang on. X 12 from x is greater than 0.
Yeah.
So then you solve this. X is greater than or equal to 7.
Not x.
Y, sorry.
Yep. Y is greater than or equal to 7 is the range. So for part B, just by looking at it, what's the range for that?
X is greater than or equal to 7. Oh wait.
Your domain is x.
So if the range is a domain, so y is greater or equal to 0.
Yep. How do you find inverse function?
Which question's that?
Same one. The -1 thing.
Oh, so if y equals 2x plus 7,
yeah,
then you substitute the y and the x and
okay. Yeah, you know what you're doing there. What is the relationship between the graphs of a function and its inverse function?
They intersect.
They are. You know how you swap the x with the y and the y with the x?
Yes.
They are a reflection in the line y equals x. Okay, and that's why you're swapping the x and the y. So this one, the range, find that same thing. Find the range, okay. For which, what is question 12a about?
So when you find the inverse, which is
that's long, man. Sketch it in your calculator. X squared plus 6x minus 4.
X squared plus 6x minus 4. So yeah, state the least value of a for which f minus. Is it just a no? That's 4 marks. Can't be just a minimum point.
It's just a minimum point.
I swear it was 4 marks.
So, keeping in mind that you're cheating by having your calculator sketch the entire graph for you.
Oh yeah, so it's -3, -13. So least value of a -3.
Yep. Bingo. Given that a is equal to 0, find that stating its domain. Okay. So I think you're good for that. That it doesn't have any repeating y coordinates. And so, yep. The functions, inverse, composite. And then solving.
What was composite again?
Sorry?
What was composite again?
Composite is just when they put two together, like the f of g of x. G of f of x. Okay, 17a. How do we do that?
Point that and that a turning point in the graph. Sketch ahead. So it's times the x by 2. So it's gone like so. 4 minus 3 goes to 8 minus 3.
So x was 4.
So now it's 8.
Hold the phone. X was equal to 4. Now 2x is equal to 4.
Right.
Because f of x became f of 2x.
So it's 2?
Yeah.
I don't like that.
And then
2x 4, so x equals 2. And then if f of x equals 9, so then 4.5.
yeah. So that's 2.
But then you've got to add 1 on the, you got to go up by 1.
Yep.
So minus 2 and 4.
Yep. And what's this modulus?
It makes everything positive, so that a would be like 4, 3.
And the b?
Stays the same.
What if it was minus 4 minus 3?
It'd be 4, 3.
It would not. It would be just the y, I believe, because it's around everything. It's not in the bracket next to the x. So that would change the x to be positive. This changes the y to be positive, because you could bring the modulus to the other side.
So it'd be minus 4, 3.
Yep. And this would be 4 minus 3. And then this is similar. How was that for you, Saba?
It's alright.
So I think you're good. We got way into these, yeah. Sometimes you can just look at it and you can see the domain is from minus 5 to 7 and the range is down minus 2 up to 18.
Yeah.
Anything in particular you want to do? So that's the first 2 chapters of year 2 anyway. What are we doing next time?
Just exam questions, same thing really.
Alright. Pure chapter 3 onwards, or year 2 or something else?
Year 2 defo, because yeah, I don't have my book.
I can bring up contents if I can find it. Yeah, so just practice this proof stuff.
Yeah, that's what you were gonna say. Trigonometric functions, as in, do you know when it says let the go from this to this?
I don't know what that means.
So like if it's
show that tan 2x is identical to sec something crazy, that type of thing.
Yeah.
Trig identities, I think.
Maybe, yeah.
I think that's what you mean.
It's basically start from this so you can get the answer that we've already given you.
Yeah, and they usually use the 3 equal sign in between.
Yeah.
So it's not solving, it's actually like monkeying around with it. Yeah, until it gets... I know it. Any questions in general?
No.
Alright, well done, Saba. You did great. I look forward to talking again next week.
Thank you, bye.
Have a good week. Goodbye.
Thank you.